right, we're going to look at some more multiplication properties for exponents. Now this property is called raising a power to a power. So that means when I have one base and two different powers. So we've already looked at doing something that looks like a to the m times a to the n. So if I have two different bases and the same, and then two different exponents, I would put those together by adding my exponents. But when I have just one base, like this, I have one base of a and then I have m to the n. What I do is multiply those together, m times n. Also, if I have two bases, like together inside of parentheses raised to a base or to a power, then each one of those bases gets the power. It looks like that. And we're going to do some of these examples. It's kind of easier to explain with some examples. So this has one base, the base is 5, and I have two exponents. I have 5 to the 4th to the 2nd. So I would say 5 to the 4th to the 2nd. So that's why it's called a power to a power. Right? I have a power and it's raised to on a power already. So if I wanted to just look at what the rule is for exponents, this power means I have two of whatever's in the parentheses. So in this case, it's 5 to the 4th times 5 to the 4th. So I have those twice. So if I write it this way, now it looks a lot like what we did before, which is two bases, two exponents, and we add the exponents together. 4 times 4, or I mean 4 plus 4 is 8. So 5 to the 8th. But we don't want to have to write them out every time because 2 is not too bad, but it can get to be like, 12 or 14, and then I don't want to write this out 14 times. So I could just look at my two exponents right here. Well, maybe if I don't cover them all up, we can look at them. 4 and 2. 4 times 2 is 8. And that's how I get that number right there. So power to power, you actually multiply the bases together instead of adding them. So x squared to the 5th power would be x to the 10th. 2 times 5 is 10. Q to the 10th to the 10th. One base, two exponents, multiply. 10 times 10 is 100. Q to the 100. Now this one, we're going to start throwing in more than one variable. So I'm going to look at this one in parts. First I'm going to look at just this part right here that's got the c squared squared. And I'm not going to worry about that c to the 3rd. So this is one base, two powers. So 2 times 2 is 4. So this is really just c to the 4th. And then I've also got my c to the 3rd. Now I have two bases and two exponents. So my other multiplication rule applies, and I'm actually going to add these together. So I have c to the 7th. Okay, this one over here, x cubed to the negative 1. We're going to look at that one first. Now this is going back to our negative exponent rule. But before I do that, I'm going to just go ahead and do my multiplying. So 3 times negative 1 is negative 3. And I'm just going to let that sit for a minute because I always want to do the negative last. So I'm going to come over here and look at this one. X squared to the 5th. 2 times 5 is 10. Now I have two bases that are the same, so I'm going to add my exponents together. A negative 3 plus a 10 is a 7. So I have x to the 7th. And see, I didn't even have to do anything with my negative because once I got down to here, since I combined them, it kind of just disappeared on me. So that's kind of why we want to leave the negative. We'll just hang on to it and bring it down until we kind of get to the very end, and then we'll, if we still have it, then we can, move it to the bottom if we need to. All right, let's look at these. So I'm going to start with this one right here. Got some negatives in there again, but that's okay. So I have a positive 2 times a negative 2, which would be a negative 4. And then here I've got a positive 2 times a negative 5, which would be a negative 10. Doesn't look like I'm going to get rid of my negative this time, because when I add negative 4 and a negative 10, I get a negative 14. So there's nothing left to do. So I'm going to have to deal with the negative sign. If you remember, negative means that it drops down to the bottom. So I'm going to put my t to the 14th on the bottom, 1 on top. Since I moved it, I don't have that negative anymore. So now it's just a t to the positive 14. And that's it. Now, this one has two numbers or variables. You can have different variables in here too, but two different values, both raised to this power of 3. So the power of 3 means that I'm going to have 3 of these right here, right? 5y times 5y times 5y. There's 3 of them. That's what that means. Well, if I have 3 5s, then what I have is 5 to the 3rd, and I have 3 y's, then I have y to the 3rd. But again, we kind of want to skip over this step. So if I have more than one number in my parentheses to a power, I just give that power to each thing or each number in the parentheses. Now I can take this one step further because I can do 5 to the 3rd. It's 125. And of course, we can't do anything else with the y cubed, so we're just going to leave that as y cubed. So why don't you try this one here and see what you get, and then I will do it for you. Okay, so we have this negative here, and I think I want to do it first because I'm not seeing that it's going to go away, and if I start giving it out, I'm just going to end up with more negatives. So let's draw our top and bottom, and we'll just move this whole thing to the bottom. And since that's just a 1, it doesn't really change anything, and that's it. That's my whole answer. So I think if that had been a 2 or a 3, I might have done it differently, because since it's just a negative 1, really all that means I'm going to do is flip my number over. So that's all I did. All right, why don't you give number 9 a try? Okay, so in this case, I have this 3, and I have 3 numbers, so I'm going to go ahead and oh, well, that was not nice. I'm going to give each of those the 3, so 2 to the 3rd, x to the 3rd, y to the 3rd, and then I got this x squared over here on the end, and I'm just going to bring it down and keep it. Okay, now 2 to the 3rd is 8, so I'm going to go ahead and put 8. But what I have here now is I've got an x to the 3rd and an x squared. Same base, 2 exponents, then I can add those together. So if I have 3 x's here and 2 x's here, I've got 5 x's. And then I just put the y on the end. And that's my answer. Right, number 10. Negative 5x squared. So this has got those negatives in there again. Remember, when we're squaring a negative, we want to make sure we keep it like this with the parentheses because it changes our answer. And then we'll bring the rest of this down. So negative 5 squared is a positive 25. That just stays x squared. And this one is a 5x squared. Now, my x squareds are the same. It's almost like I got 25 apples sitting over here, and I got 5 apples sitting over here. And if I want to write this simplified, I wouldn't kind of keep them separate. I would say how many I have total. These are called like terms, and I want to kind of stick them together. So 25 and 5 is 30. So what I really have here is 30x squared. So I'm going to combine them by adding. All right, and the last one. So this one, they're going to throw some decimals in here. So I have 2, so I'm going to end up with 2 squared and then x to the negative 6, because now I got a power to a power here. Negative 3 times 2 is negative 6. Then the 2 to the 0.2 gives me 0.04 x squared. 2 squared is 4, x to the negative 6, and then 0.04 x squared. So I want to combine these, but I'm going to have to kind of stick them together here first. So this number and this number, since those are both my numbers, I'm going to put them next to each other. So what I have is 4 times 0.04, and then I have x to the negative 6 times x squared. 4 times 0.04 is 0.16, and then 2 bases, 2 exponents means I'm going to add them. So I have x to the negative 4. So this looks pretty good except for that negative exponent, and we always want to get rid of that. So that means that x is going to have to go to the bottom. So I've got 0.16 over x to the 4th. And that is it.